Hello everybody, today I can find missing sides of parallelograms and trapezoids using their properties and algebra. So in the last lesson we spent a lot of time talking about the different properties, so let's take a look at it here. Now this lesson is going to be specific to sides. The next lesson is going to talk about angles, so let's talk about what properties of sides we have here. In a parallelogram, we know that opposite sides are congruent. We know that diagonals bisect each other. The diagonals are cutting each other in half into congruent segments. We know that a rectangle has congruent diagonals. We know that consecutive sides are congruent in a rhombus. Don't forget that squares have all these properties. And something else that's going to come up in this lesson is this property. Diagonals are perpendicular to each other in a rhombus and a square. So these are the lessons that are these are the properties that are going to come up today. I think we're also going to talk about the isosceles trapezoid. In the isosceles trapezoid, we have congruent legs, and we also have congruent diagonals. So those properties are going to come up as well. So, ABCD is a parallelogram. Find the measure of AD and BC and explain your answer. Well, if this is a parallelogram, and in this problem we're dealing with AD and BC, well, opposite sides of a parallelogram must be congruent. Therefore, those sides must be congruent. So the algebra, I'm going to set them equal to each other and solve. I bring everything to one side. I isolate, add or subtract first. I divide last. I get x equals 2. Now the question is not asking for x, it's asking for the measure of AD and BC. So AD and BC. AD is 7 times x minus 7. BC is x plus 5. They're both 7. And they should be the same thing since they're the same. So explain your answer. Well, why did I set these equal to each other? What property did I use? A parallelogram has opposite sides congruent. So that's what this lesson is. We're going to use the properties that we talked about in the last lesson, but we're now going to apply algebra to that. We're going to use those properties and create equations to represent the situations. With these segments, it's almost always going to be congruent. So it's going to almost always be equal to each other. So when in doubt, with segments especially, set things equal to each other. SFAT is a rhombus with AE equal to 2x minus 3, and EF equal to 5x minus 21. Find EF and explain your answer. Well, these two segments are congruent. So I want you to do two things. I want you to give me an equation to represent the situation, and I want to know why. So take about 15-20 seconds to set up your equation and tell me why. What property are we using that applies to this problem? Okay, your equation. Well, let's actually not start with the equation. Let's start with the explanation. What property applies here? Well, it's a rhombus, and a rhombus has diagonals that bisect each other. Remember, rhombus has all the properties of the parallelogram as well as those three additional properties. A rhombus has diagonals that bisect each other. This is one of the properties of the parallelograms, and the rectangle, rhombus, and square have all of those. The diagonals that bisect each other. So, since they bisect each other, those two segments are equal. So I set 2x minus 3 equal to 5x minus 21. I do the algebra. And I get x equals 6. What's the question asking for? EF. Well, EF is 5x minus 21. So it's 5 times 6 minus 21. Use a calculator if you need to. EF is 9. So again, for the most part, I can't say 100% of the time, but for the most part, we have a lot of properties that deal with congruence. So for the most part, if they're congruent, you're going to set them equal to each other, the two expressions. And then the property, you have to identify which property we're using. In this case, these are the two pieces of a diagonal, and I know that since the diagonal bisect each other, that they must be equal. I don't want to go through every problem with you because, they're all similar in the fact that you're pretty much going to be setting the expressions equal to each other, but you need to identify which property it applies to. And that's, again, based on what we did in the previous lesson. So I don't want to do that. I don't really want to do that. I don't really want to do that. You know what? Let's just have you do one on your own. And then there's a different type of question afterwards. So let's take a look at number 7. I want you to try it on your own. So draw a picture, obviously. Try it on your own. So pause. Try this problem on your own, and then unpause, and then I'll go over it. All right, now that you tried number 7 on your own, I'm going to draw a picture. A, B, C, D. AB is x plus 4. BC is 4x. AC is 6x minus 2. And BD is 3x plus 4. So, what do we have here? I have a side. I have a consecutive side. And then I have the diagonals. Well, in a rectangle, is there a relationship between the consecutive sides as far as the measurements of the consecutive sides go in a rectangle? Are consecutive sides congruent in a rectangle? No. How about diagonals? Do we know anything about the diagonals being congruent in a rectangle? Well, if I look back here, boom, here it is. A rectangle has congruent diagonals. So, my explanation, it's not asking for one, but I'm still going to write it. A rectangle has congruent diagonals. So I'm going to set the diagonals equal to each other. I'm going to set 6x minus 2 equal to 3x plus 4. This stuff was extra information. There is no property for the rectangle talking about the consecutive sides as far as the lengths go, but I do know that the diagonals are congruent. So those are the ones I'm setting equal to each other. I do the algebra. I get x equals 2. Now, it's asking for AD. Well, AD is congruent to BC because opposite sides of a rectangle are congruent. So if BC is 4x, then AD is 4x. So AD is 4 times 2. AD is 8. I like this question. It's one of my own questions because it really talks about the understanding of what you need to know. All right, you need to know what properties, which shapes have. You need to know that a rectangle, there is no relationship between these consecutive sides. But I do know that a rectangle has congruent diagonals, so that's what I use to create my equation. And then once I had that, I still had to use another property because it wanted AD. Well, AD has nothing to do with the diagonals, but it is congruent to the opposite side because a rectangle has opposite sides congruent. And I have my x value and I sub in from there. All right, there's one more type of question that you're going to see in this lesson, and that's going to be number 9. And I got, I think, 3 examples on this. In the diagram of rhombus PQRS, the diagonals PR and QS intersect at point T. The diagonals of a rhombus. There's a lot of stuff going on with the diagonals of a rhombus. The diagonals are perpendicular. The diagonals bisect each other. So, the diagonals are perpendicular, and the diagonals bisect each other. So if PR is 16, then that means that each half is 8 and 8, and if QS is 30, that means that each half is 15. Since they're perpendicular and we have right angles, I have a right triangle hidden within the bigger picture. So it might be easier to kind of redraw it. And it doesn't matter which triangle I picked, because there's 4 right triangles here. They're all congruent. So this is 15. This is 8. It wants the perimeter of PQRS. Well, in order to find the perimeter, I would first need to find one side. That's what I need to find. So I have a right triangle. I have no angle involved. I have just sides. Well, we learned this a couple units ago. When I have a right triangle and only sides are involved, the Pythagorean theorem. All right, let's see if you remember how to do Pythagorean theorem. A and B are the legs, 8 and 15. 8 squared plus 15 squared equals c squared is x squared. Use the calculator if you need to. I'm just kind of doing the arithmetic here. X is 17. So I know another property of the rhombus is that all the sides are the same. So if this side is 17, then all the sides are 17, and the perimeter is going to be 68, since all the sides of a rhombus are the same. So when you have a rhombus or a square, and they give you the diagonals, you need to use the property diagonals are perpendicular to each other, and the property diagonals bisect each other. You're going to have a right triangle created within the rhombus, and you're going to have to use Pythagorean theorem to find one of the sides. It's a it didn't come up much. It's been coming up more in the regions as of late, and it's not difficult if you are prepared for it. Number 10, a square has a diagonal that measures 4 inches. So let's get a square. We're talking about the diagonals of a square. So you need to know that they're perpendicular to each other and that they bisect each other. And if it's a square, that the diagonals are also congruent, so all 4 of them are congruent. In a rhombus, I don't know that all 4 of them are congruent. I just know that the pieces of each diagonal are congruent. But for a square, since the diagonals are congruent, they're all congruent. It makes it a little bigger so I can actually write on it. If the diagonal is 4, that means that all of these are 2. It's asking for the length of one of the sides. Well, within my shape, looking for a fun color. I'm not seeing one. I always end up going orange. Within my shape, I see a right triangle. I want you to try and finish the problem from here. Again, as a hint, once I have a right triangle and I have only sides involved, I do Pythagorean theorem. So please pause, finish the problem on your own, and then unpause. Okay, my legs are 2 and 2. My hypotenuse is x. 4 plus 4 equals x squared. 8 equals x squared. Radical. It wants the answer in simplest radical form. So if you remember that, if you don't remember that, we have a separate video on that. 1, 4, 9, 16. I like to always have my perfect squares written out whenever I'm reducing radicals. 8 would fall here. What can I divide into 8? Well, only 4. So my answer would be 2 rad 2. And that's it. So I think there's one more example like that. I'm going to let you try that on your own. And again, whenever you have a square or a rhombus and we're talking about the diagonals, I know that the diagonals bisect each other. I also know that they're perpendicular to each other, so you have right triangles formed, and you're going to use the Pythagorean theorem to find the missing side. So what are we doing in this lesson? We're using the properties that we talked about in the last lesson, specifically the ones dealing with the sides. Those are the ones that I kind of circled here or marked up. The next lesson is going to deal more with the angles. Identify which property you're using, because you might need to explain it within a problem, and that's what I'm asking you to do on these. Set up an equation to represent the situation. That's the majority of it. That was kind of the first bunch of problems. And then at the end, when you're specifically dealing with a rhombus or a square and the diagonals, you're going to have a right triangle hidden within the picture, and you're going to have to use Pythagorean theorem. The classwork/homework is going to be to finish quadrilateral properties with segments, and I hope everyone has a great day.